Well, good evening. Today's lesson is on 3-6, and this is actually going to be kind of a continuation of a lesson we did a couple lessons ago when we did greatest common factor. Except that today we're going to be talking about the least common multiple. And I've got a guest friend here that's going to help me teach. Say hi.
Hey guys, it's Kevin again.
So let's talk, before we even get off this first slide, Kevin, let's talk about what least common multiple means. So what's another way to describe least? Least, we're looking for what?
The thing that doesn't appear the most, the number that...
Okay, the one that happens the least. In this case, what would we mean if I have a whole bunch of numbers? The one that is the least, not the least common.
The lowest.
The smallest, right.
Smallest.
Yeah, the lowest number of the small. So that's what we're going to use in this case. So we're looking for the smallest. What does the word common mean? Like, for instance, things that Kevin and I have in common. We like to make math videos. Okay. We both like math. We're both guys. So, okay, those are things we have in common. We both have a connection to the Lexington School. So in this case, we're going to talk about something when we're talking about two numbers, and we're looking for their least common multiple.
So it's the thing, it's what the two numbers have in common?
Right. It's going to have to work for both numbers.
Okay.
So it's going to have to work for Kevin's number and my number. So this is a really good lesson to do with two people. So he's going to represent one of the numbers in each case, and I'm going to represent one of the numbers in each case. And to find a common, let's put the last word in here. Multiple, what does multiple mean? A multiple, what are the multiples of 5? So things like 5, 10, 15, 20. Right. So you just start counting by 5s, right? The multiples of 4 would be things like 4, 8, 12, 16. The multiples of 10 are 10, 12. So multiples, a multiple of a number is a number that number goes into. Yeah. Okay? So Kevin is 12 years old. So multiples of his age would be things like 12, 24, 36. Now, let's go back to that word common. If Kevin has a number and I have a number, to be a common multiple, both of our numbers have to go into the same number. That's what common multiple is. Now, we could always just multiply our numbers together. That would always work. Yeah. Okay? Because if I do, let's say Kevin's number's 12 and my number's 20. 12 times 20, well, is 240. And the way we got it is we multiplied the two numbers together. So obviously 12 goes into it and 20 goes into it. But the question is that the smallest number that works, or can we find another one before that? So we're looking for the least common multiple. Not to be confused, even though it's a three-digit acronym, don't confuse that with GCF. Okay, so that's the introduction, and hopefully that'll put your mind in the right place. So let's talk about how to do it. Sound good?
I actually think I know the least common multiple of 12 and 20. Is it 60?
12 and 60 would be 60. Good job. Mm-hmm. And we'll talk about how you find that, and maybe we'll even use that as an example. That's a good one. Okay. All right. So, again, just like when we did GCF, there are 3 ways. Again, don't let that confuse you. But the 3 ways are exactly the same as before. So what were the 3 ways we could find GCF? Well, one way is we could list out all the factors. Except this time, we're not going to list out factors. We're going to list out the multiples. So take both of the numbers, like 12 and 20, and just write out their multiples and find one in both lists that's the smallest. That's in common. All right, another way to do it, as you can tell, that could take a long time because there's an infinite number of multiples of a number. There were not an infinite number of factors. Eventually, we ran out of factors, but with multiples, you could go on forever. So that's probably not going to be our favorite way to do it, and sure enough, it isn't. Oops, I'm dropping my stylus. Okay, the second way, just like before, we can do division ladders. Yeah. However, once we get the division ladder done, how to find the LCM is going to be a little bit different than what we did for GCF. It actually turns out we find the GCF on the way. So you just go a little bit further and you can find the LCM doing the same work. So that'll actually be almost the same. And the other way is to do the factor trees, which are fun to do. I totally get that. I like doing factor trees as much as you guys do. The catch is finding the right answer after you do the factor tree. That can be a little bit tough. So let's go through each of these and let's talk about exactly how you use each of these methods. All right, so let's start out by listing the multiples. So let's say we're going to find the LCM of 10 and 12. All right, so what we're going to do for this one is we're going to take each number and we're going to list its multiples. Now we start with the number itself. Yeah. Because 10 is a multiple of 10, because 10 times 1 is 10. All right, so the next multiple of 10 would be? 20. Yep, and then 30, 40, 50, and then 40, and 50, 60, and I could just keep going and going and going. All right. All right, so now take the next number, which is 12. Now this is going to be a little bit harder. So multiples of 12. 24. If I double it, I get 24. If I multiply by 3, 36. I get 36. There you go. Keep going.
48.
Good.
60.
60. And hold on a second. Why did I stop there?
Because both these numbers have 60.
Yeah, and the next one would have been 72.
72.
All right, we can stop right there. And right here is the first number that's in both lists.
Yep.
Now, there'll be other numbers that'll be in common. Like we know eventually 120 will be in this list.
Yeah.
And if I keep going here, obviously 12, if I keep taking multiples of 12, the 10th one will be 120. So there'll be other numbers that will also be in common. But remember, we're looking for the least common multiple. So we would say that the LCM of 10, 12 is equal to 60, and that's how we say it. That's how we write our work. Okay, so that's by listing out all the factors.
Got it.
All right, now let's do the second method. The second method is by doing a division ladder. So just like before, let's take our two numbers. Let's do the one that Kevin and I were talking about before, where we did 12 and 20.
20.
All right, and so let's do a division ladder here with 12 and 20. So what's a factor that goes into both 12 and 20? What's an easy one? 2?
2.
Yeah, let's just start with an easy one. So 2, if I take it out, I get what? 6 and 10. Okay, are we done?
No.
No, because I just drew another line. Why did I draw another line?
Because these are both even and they can be divided.
Right, he's exactly right. Everybody agree? They're both even numbers, so I can take another 2 out, and what do I get then?
3 and 5.
All right, now this looks familiar, right? Isn't this exactly what we did for GCF? And to find the GCF, Kevin, what do I do with the 2's that I took out over here?
Don't you multiply them together?
Yeah, multiply them together, and so in this case, the GCF
is
4. The only catch is that's not what we're looking for, is it?
Nope.
No.
Wait, do we do 3 times 5?
Yeah, so here's what we do. No, more than that. So what we're going to do, we still have to find the GCF, but now what we do to get the LCM, which is what we're looking for, we take the GCF and we multiply by these two remaining numbers, both the 3 and the 5. So 4 times 3 is 12, and then 12 times 5, sure enough, equals 60. And Kevin was exactly right. His guess at the beginning that the LCM of 12 and 20 was 60 is correct. Sure enough, if you look at it, 12 goes into 60 how many times?
It goes in 5 times.
Goes in 5 times. And 20 goes into 60 how many times?
3 times.
3 times. Notice that those were actually the numbers that were at the bottom. That's not actually a coincidence.
So we can,
it turns out that 20 times 3 equals 60, and 12 times 5 also equals 60. That'll always work.
Oh, wait.
So this is actually, there's actually a lot of cool stuff happening in this one. So the nice thing about doing it by division ladders, okay, you don't have to list out all those multiples like we did before, so it's going to save time. And if I give you a question on a quiz or test, a lot of times I'm not just going to ask for the LCM or the GCF, I might ask for both.
Yeah.
And so here you've done both problems with one set of work, and you are done. Okay? So I'm actually going to take away some of those lines I just drew so it's not confusing.
Then again, you could also do this. You could, instead of doing that times that times that, you could just do that times that. Like to see.
So yeah, you could start out by doing, because of the associative and commutative properties, you could do 3 times 5 first and get 15, but you still have to multiply by the GCF, and that was how you get 60.
Yeah, well, that way you could sort of like checking it, because if...
okay, I see what Kevin's saying. What's Kevin saying is, look, if you know this is true and you've done it, you actually could circumvent this bottom row. You could actually just multiply one of these diagonals, and that would also equal the LCM of 60.
Yeah, and then you could see if the GCF was wrong.
Yep.
If that equals the wrong thing.
Yep, that's good. Now, there is one catch with division ladders.
Yeah.
Okay, and here's what it is. Division ladders work for GCFs on 2 numbers, or you can do one with 3 numbers.
But
there is a catch. No, well, you can't do common factors or common multiples if you only have one number. But here's the catch. If you're doing a division ladder with 3 numbers and you're trying to find the LCM, which is what we're doing today, there is a catch with division ladders that you have to be a little bit sneaky. And we're going to talk about that a little bit later. It actually, just like we have guest teachers when we do the flip videos, we have something that we call, here at the Lexington School, we call it the Annie Varner method. And if you guys know Annie Varner, she's one of our 8th graders, and she came up with this cool little trick on how you can use division ladders when you have 3 numbers and you're looking for LCM. And I will show you the Annie Varner method at the end of this video. So stay tuned for that. But let's go on. We still have one more method. We've listed out all the multiples. We've used division ladders. So now let's do the factor trees, because factor trees are fun.
Yes.
So let's go ahead to prime factorization. And let's go ahead, I'll pick 2 numbers. How about 25, 35? Let's do 3 numbers this time. Let's do 25, 35, and 50. All right, so let's do the factor tree for 25. What's 25?
That would be 5 and 5.
5 and 5, and they're both prime, so I can circle them right away. I'm done. All right, what about 35? 35 breaks into?
Doesn't that 6?
Nope.
No, 5 and 7.
Yeah, 5 and 7. 6 would go into 36 or 30, but not 35. Okay, so 5 times 7, and finally 50. Now 50 you can break up a couple different ways. I'm going to break it first into 5. Yeah, you can do 25 and 2. I'm going to break it into 5 and 10, and then I'll break the 10 into
5 and 2.
5 and 2. All right, now we're not done yet. We still have to write the prime factorizations. I'm going to switch colors just to emphasize that. So 25 is actually 5 to the second power. 35 is 5 times 7. And 50 is 2. We always start with the smallest factor first, times 5 squared. Now, if we were doing the GCF here, what we would look for is we would look for a number that's in all 3 factorizations. And I think you can see pretty quickly the only number that's going to be in all 3 is each of them have a 5. The first and last one have 2 5s, but not the middle one.
Yeah.
So you've got to find something that would go into all of them. So if we had to do GCF, I'm just going to put it over here because that's not what we're focusing on today. The GCF would be 5.
Yeah.
Okay, but what we're focusing on today is the LCM. Now the LCM is a little different. Instead of looking at what is the minimum that is in each of the factorizations, we're going to look at the most each time a factor occurs. So what we're going to start with is we're going to write down all the factors that occur here. So I have a 2, a 5, and a 7. It doesn't matter which ones they occur in, but we need at least a 2, a 5, and a 7 because there's at least because those are the 3 prime factors that appear in any of the numbers. It doesn't matter if it appears in 1, 2, or all 3. All right, and now what we're going to do, instead of writing the minimum power, we're going to write down the maximum. So how many 2's do if you look at all 3 numbers, the most 2's any of them have is the 50 has 1 2, so we'll put a little 1 there. But the 5's, even though the middle number only has 1 5, both the first and last have 2 5's. No, we don't need a collective. We just need 2. Okay? And then there's 1 7 in the middle number, so we need to put that in. So what we get here is 2 times 5 squared times 7. If I gave you a Lego box, and it had the numbers 2, it had 2 5's, and it had a 7 in it, could you make each of the numbers 25, 35, and 50? Well, yeah. You could take the 2 5's and snap them together, and that would give you 25. You could take that apart, put it back in the box. Now, with the pieces in the box starting over, could you make a 35? Sure. Take out the 5 and 7, stick them together, you got 35. Now, could I make a 50? Well, this one's going to be a little harder. You'd have to take a 2 out and both of the 5's. The only piece you wouldn't use is the 7. Snap them all together, and you get a 50. All right? So, that's kind of the idea of LCM. You have to have enough pieces that you're able to make any of the individual numbers in the prime factorizations, okay, and then you multiply them all together. Now, I'll explain that. I'll try to explain that, I should say, a little bit more in class. But what we do to finish this one up is just like we did with the division letters. We got to multiply all this junk together. So 5 squared is 25, times 2 is 50, times 7 is 350. And let's just check for a second. Do all of my numbers go into 350? Well, obviously 50 does.
And obviously
it goes
35.
in 7 times. Obviously 35 does. It goes in 10 times. Good observation. 25 is a little harder, but it goes in. Think about money. If I had exactly $3.50 in quarters, how many quarters would I have? Well, let's see. There's 4 and a dollar. It'd be 12. It'd be 14 quarters.
Or you can just think about this. Anything that ends with 50, 25 will go into 50. So
yeah, exactly. Yep, he's exactly right. All right, so that's how you do it with prime factorization. So we've got our 3 different methods. We could just, by the way, we could have done the other methods on this one too. We could have written out, 25, 50, 75, 100, write out all the multiples of 25. Yeah, exactly. Ooh, that was a good reaction. We could take the multiples of 35. 35, 70, 105, 140. Again, the multiples of 50 wouldn't be bad. 50, 100, 150, I could do that. And then we would look through those 3 lists, and we'd have to keep going and extending them until we got to 350 on all 3 lists. That's going to be a lot of work. So that's not really our favorite method. There's the division ladder, but again, we need a trick in order to use it on 3 numbers. And then finally, there's this idea of doing prime factorization. Okay. I still like division ladders the best. So let's go back and let's learn the Annie-Varner method. So let me go forward first for a second here. And we've got some practice problems for you. 24 and 30 and 6, 8, and 14. And what I'm going to do, I'll show you how to do the Annie-Varner method on the second one because it's got 3 numbers. So let's first do 24 and 30. And actually, why don't we try to do these all 3 ways? So if I did 24 and 30, if we started listing out multiples, we'd have 24, 48, ooh, this one's going to be hard, 72, 96, 120, I think. And actually, I think 30 goes into 120. So that's probably going to work, so we'll stop there. The next list will be 30, 60, this one's a little easier, 90, 120. And sure enough, double check the list, and the first number that's in both lists is 120, right?
Yeah.
Okay, that worked. An easier way.
Fun, though.
No, it was not fun.
No.
24 and 30, let's do a division ladder. And actually, instead of taking little numbers out, what goes into 24 and 30? Doesn't 6 go in?
Yeah.
And you get what, 4 and 5?
Yep. But
We're done.
Oh.
6 is the GCF, but that's not what we're looking for. Now
6
multiply
times
6 times 4 times 5. 6 times 4 is 24. Times 5 is 120, and boom. The LCM, if I multiply the 6 times the 4 times, oops. If I multiply the 6 times the 4 times the 5, go straight across, so the GCF, 6, times the 2 remainders, sure enough I get 120.
Yeah.
Okay, and then the last way to do it would be factor trees. We don't actually have enough room here to do it by factor trees, but if I quick did the factorization, I think I can probably do this without doing the factor trees. 24 is 3 times 8, and 8 is 2 to the third power, so it'd be 2 to the third power times 3.
Okay.
And 30 is 2 times 3, which is 6 times 5. And so what numbers would we need to do to have in the GCF? Well, we need a 2, a 3, and a 5. And we would need a total of 3 2s because of that first 2 to the third.
Yeah.
So it'd actually be 2 to the third times 3 times 5. So that's 8 times 3 is 24. 24 times 5 does equal 120. So all 3 methods would give us the same LCM. Now, the Annie-Varner method, when you have 3 numbers, is what you do for finding the LCM is you actually do it in 2 steps. First, you take the first 2 numbers. Okay, and you find. There we go. There you go. You find the LCM of those. So you can take a 2 out of 6 and 8, and you get 3 and 4. Okay, 14. Now 2 times 3 times 4 gives me an LCM. The first 2 numbers, just of the 6 and the 8.
Oh, okay.
We'll get to the 14 in a minute.
Okay.
So 2 times 4 is 6, so you get 24.
Yeah.
All right, now take 24. So that takes care of these 2 numbers. Okay, now bring the 14 down and do the same thing for 24 and 14.
Oh.
So what goes into both of them? 2 does. We get 12 and 7. And unfortunately, nothing goes into 12 or 7. So here's what we're going to do. We're going to take this LCM across the bottom. We're going to multiply 2 times 12 is 24. And 24 times 7, that's going to be 7 times 4 is 28. It's going to be 148.
I never think about these.
Let's take a look at this. Does 6 go into 148? Well, you'd have to actually divide it.
Yeah.
It will go in. It's going to turn out that it goes in, let's see.
Should we just not bother our brains to do this?
Okay, we just had to pause the recording for a second. Yeah. Sorry for all of you intrepid people out there trying to get a bonus point. We realized that I made a math mistake right here. 7 times 4 is 28. Carry the 2. 7 times 2 is 14. This should be 168 here. Yeah. So 6 goes into 168 twice with a remainder of 4. And 6 will go into 48. So yes, it goes in 18 times. 8 goes into 168 exactly 21 times. And 14 goes into 168 12 times. So it does work, and sure enough, it is the smallest number. Now just imagine doing multiples of 6, 8, and 14 until you got to 168. It would take quite a while. All right, we're running out of time. We're almost up. We're over 18 minutes, so we're going to go ahead and close this out. Bye. So this is Kevin and Mr. Gunn, and we're saying thanks for watching our video, guys, and hope this helped you gain an understanding of least common multiple. We'll practice that tomorrow in class.
Got it.
All right, take care, guys. Good night.
Good night.